Good morning to one and all present here. It's an absolute pleasure to welcome you all to the 17th generic talk series on C-DAC's technological advancements for shaping India's future, organized by R.M.D. Engineering College. To begin with, may I now request Dr. S. Shalini, Associate Professor, Department of Physics, to kindly welcome the gathering. Please, ma'am.
Thank you, ma'am.
Yes,
Good morning and greetings to you all from the Science and Humanities Department, R.M.D. Engineering College. On behalf of the management, the principal, the faculty members, and on my own behalf, I welcome you all to the Generic Talk Series 17, organized by R.M.D. Engineering College on the title C-DAC's Technological Advancements for Shaping India's Future. This special initiative is taken by our management on promoting quality technical education and producing quality engineers for the students to attain information beyond the curriculum in various fields through the lectures delivered by the respective field experts. Today, we have with us in our midst Shri E. MAGESH, Director General, Center for Development of Advanced Computing. We welcome you, sir. We appreciate your willingness to share your knowledge and expertise, and I'm confident that everyone here will gain valuable insights from your presentation. Let's open our minds and hearts to new ideas as we come together to learn new facts and share knowledge. Thank you.
thank you, ma'am. It's my pleasure to invite Dr. P. Usharani, Professor, Department of General Engineering, to introduce our esteemed chief guest. Please, ma'am.
Honorable Chairman, sir, most respected dynamic Vice Chairman, sir, beloved Principal, sir, treasured HOD ma'am, faculty members, beloved parents, and my dear students. Happy morning to all. I thank the management for giving me an opportunity to host generic talk series on C-DAC's technological advancements for shaping India's future by Shri E. Mahesh, Director General, Center for Development of Advanced Computing, C-DAC, Ministry of Electronics and Information Technology. I welcome you, sir. I thank Shri E. Mahesh, Director General, C-DAC, for accepting our invitation in spite of his busy schedule. Thank you, sir. He is spearheading the national mission programs like the National Supercomputing Mission, Microprocessor Development, and C-DAC Mission Mode programs in HPC, AI, cybersecurity, quantum, microprocessor, and next generation computing. He has more than 30 years of diversified experience ranging from design engineering, project management, and delivery of turnkey projects. He has in-depth expertise in electronics and chip design, VLSI, hardware, IP, complete product cycle. He was also responsible for SoC integration, front-end to back-end, tape-out and silicon validation, delivered tested products, and management of various AIs, IC, tape-out for customers. His innovative contributions include the techniques adopted in R&D towards realizing 25 plus ASIC chip C-DAC's indigenous Series 3264-bit RISC-V based off processor called Vega and SoCs called Tejas under National Microprocessor Development Program RISC-V based chip and 96 core ARM 64-bit processor for India first HPC SoC. Safe city including ERSS and smart cities. It has put a good foundation for launch of various products and solutions, making India self-reliant and in line with the goals of Atmanirbhar Bharat and Digital India. Since June 2023, he is also assigned with the additional charge as Director General, Center for Materials for Electronics Technology. Under his leadership, CMET is continuing to develop leapfrogging electronic materials technologies such as compound semiconductors for high-power devices, ultra-high purity materials for National Semiconductor Mission, quantum and 2D materials, resource efficiency and circular economy through e-waste recycling, ceramic, and composite materials for 5G and 6G communications, etc. Under his visionary leadership, CDAC has received numerous prestigious national and international awards, a few of them NCD's Scotch E. Sanjeevani National Award of Excellence 2023, E. Prama National Single Sign-On, 35th Technology Sabha, E. Northeast Award, Nagaland Technology Sabha Award, 8th Digital Transformation Award. These are few things. Each of these awards represent not just an achievement, but also a responsibility. This is to continue innovating, to keep pursuing boundaries, and to drive India's digital transformation forward. I wish to hand over the session to Shri Magesh, Director General, C-DAC. Thank you all.
Thank you, ma'am. It's now my pleasure to invite our distinguished chief guest, Shri E. Magesh, Director General, Center for Development of Advanced Computing, C-DAC, Pune, to enlighten us with these valuable insights. Welcome, sir. This session is now yours.
Good morning to all of you. Good morning to the students of R.M.D. Engineering College and a group of institutions, the management, the faculty members. I'm extremely happy to be part of this series of program, and thank the management for giving me this opportunity. And so as I was introduced, I'm also heading both C-DAC and CMET. So I thought that no, this is more connected to computing. I did not concentrate on the materials aspect, but I'll try to cover that also today. So CMET, CMET is a materials technology vertical of the Ministry of Electronics and IT. They focus on high purity silicon material. So there are about 20 plus silicon material and 10 to 12 chemicals and other materials used in making any chip design or wafer. So our center in Hyderabad is capable of making those high purity materials. They are also capable of making piezo-based sensors. They have capacity in additive manufacturing, because a lot of these chip designs, they need substrate, which essentially has to be fabricated in 2.5D or 3D stacking. So so far it has been a traditional PCB kind of a design, but with 3D manufacturing coming into play, we can also embed a resistor or capacitor within the additive manufacturing ecosystem. So this team specializes in making the filaments and the powders, which is essential for making these materials. So we can go up to metal grade. We use the conventional regular 3D printers, but the spool, and the reels and the powders are all made by the team here, so that can be replicated. They also have done extensive work on lithium ion batteries. So basically these are being mined and it is very scarce resource. But the secondary source could be the recycled lithium batteries, which are going to be plenty. And eventually they find a place in the dump yards. And it is going to be ecological disaster. So our team is working very closely with the industry to extract the used lithium batteries and regenerate those materials so that newer batteries could be made. They also have expertise in making magnets, permanent magnets. Basically, they are neodymium based materials. So they can extract those materials and make a powder of that, and again reform that into magnets of different shapes and sizes. So and then subsequently they could be energized and repurposed for a lot of our applications, like windmills where you need a lot of these permanent magnets, and all of these drones and copters wherein we need all of these kind of materials. We need in different sizes and forms. Our team also works on other materials like hafnium. Hafnium is a rare earth material. It's extract. It is actually found along with uranium and other atomic energy related materials. The effluent that comes out of the uranium extraction, So a lot of the component is hafnium of that. And we extract the hafnium and supply it to ISRO. Today, what you see, the booster rockets of the ISRO, they go at very high temperature. And this hafnium is a material used to coat those boosters so that the booster material doesn't melt away due to high temperatures. Today in India, CMET is the only organization supplying those materials to ISRO. And we also work on graphene technologies. So our center in Thrissur does a lot of work on graphene. So as you know, the graphene has very good properties that, for example, you can make the graphene with actuating with a mild voltage. It could become a loudspeaker. The same material, the same thing. If you can reverse the direction, it also can pick up a microphone. So that is the capability of this graphene. So we have made ultra capacitors and also based on the graphene, made some medical equipments using this graphene technology. We have a center called International Graphene COE in Thrissur. So they specialize in these areas. So we have a e-waste recycling facility, and the technology is being given to multiple TOT partners. Today, we see a lot of e-waste getting dumped, and they don't get, unlike plastic. Plastic also may, over the years, they may get dissolved, but this e-waste never does. So we have technologies to break down all the e-waste and convert that into gold, silver, and copper, and subsequently to be reused. So this is a very small gist of what CMET could do. So, but there are many other things I'm unable to cover today. But let us move to CDAC's presentation. So let me know if you could see these slides. Is it visible? Can you
Sir, it is
see
visible.
my
Yes,
slide?
sir. Visible, sir.
So yeah, C-DAC was established in 1988 when India was denied supercomputer. Supercomputers those days were made by Cray, the company called Cray. They denied this technology to India because of some export regulation at that point in time. And that's how this C-DAC center was started. And it was started in a very big way that we were able to deliver the first supercomputer within the record time and within the budget. And that was called the first Param supercomputer. So it was called Param 1000. And over the years, we were able to make multiple of these machines. So it was called Param 6000, Param 9000, and Param 10,000. Param means parallel machine. So in around 2002, we got merged with R&D, NCST, CDT, along with C-DAC. These are centers based out of Trivandrum, Noida, Bombay, Bangalore, and Mohali, and Kolkata. So they all became part of C-DAC. Today, we are about 12 centers across the country. And we also have another center in Military College of Telecommunication Engineering in Indore. So this is a very recent addition. So we are going to have become a full-fledged center of C-DAC. We are about close to 4,500, most of the people from the premier colleges in the country. Our organization structure is headed by our Honorable Minister of Electronics and IT. And then we have the coordination committee headed by the secretary and the management board headed by the DG C-DAC. And then we have a technical advisory committee headed by member Niti Ayog, Dr. Saraswat, and we have finance and account centers. So C-DAC, all the C-DAC centers have been working in multiple technologies. So we wanted to focus these areas. So cutting across these centers. Normally they are all federated centers. They have their own way of going into technology, but we wanted to create a focused approach. So we identified 13 verticals, technology advancement proliferation vertical, through which we want to have a focused mission-oriented programs, starting from HPC, quantum, artificial intelligence, strategic electronic. A lot of work on strategic electronic happens out of C-DAC Trivandrum. we have been a long-time partner for the Indian Army, Navy, Air Force, delivering a lot of technologies to them. A few would like to mention here that we have developed ultrasonic-based rocket fluid, solid-state rocket fuel measurement system. So basically, this has been used by DRDO and the ISRO. So it's a test center, it's a test setup which could be used to measure the density of the material used in the rocket fuel. So it's very important that the amount of material that gets loaded into the rocket, and people know exactly where that fuel is going to take the rocket to. So when you have a countdown and after that, you must be able to predict where the rocket is going to take the satellite to. So this fuel, measuring the fuel's density and the burn rate of that is very essential in making sure the rocket goes to that particular altitude. So we have been successful in delivering that. This is one such example, and we have been able to run underwater range in Goa for a long time. So this is where the Indian Navy come and get their seaworthiness tested, so that they can go for subsequent sail on the ocean. Then we have the Digital India RISC-V program. So earlier it was called India Microprocessor Program, and recently it has been changed, renominated as Digital India RISC-V. RISC is nothing but a reduced instruction set computing architecture. Version 5 is going on now. And then we have software testing, e-governance. A lot of work is happening in e-governance. So you could see the EPFO, the Provident Fund Office, basically the backend software is completely designed by C-DAC. When you go to Register Office in Bangalore, you will see our software being used for the registration. So these are some of few examples, many things. Healthcare, eSanjeevani is a telemedicine platform that is used extensively during the COVID time. And it's a free consultation per platform where patients and doctors come together and they get the consultancy done and they get their prescriptions and subsequently what follow-up actions to be taken. All of that is conducted online. And we also have hospital management system. Today, close to 2,000 plus hospitals across the country already using this platform. All the railway hospitals use this. Many of the AIMS use this platform. So it takes care of a patient who is coming in and then subsequently getting discharged. End to end, it manages the records, the way the patient has to move across the department. And not only that, it also manages the staff, the equipments, the labs, the reports, and all of that is handled by this platform. Next is the cyber security. We have a big team cutting across CDAC centers. We work on end system security, perimeter device security, and then we have a lot of SIEM and source solutions. And a few of them are already offered in Swachhata Kendra so that people can download and benefit out of that. Automotive technology, we have done a lot of work in autonomous vehicles. ADAS, wherein we have been able to integrate multi-sensor into that. And the communication technology, we are actually a competition to Motorola when it comes to Tetra systems. Tetra is terrestrial trunk radio. So in the past, police and all the LEAs used to use the UHF and VHF band, which is unsecure. People can listen to that. Anybody wants to listen to that. But the Tetra is something where you can encrypt the channel, so only the desired group of people can listen to what is being transmitted. And we have worked extensively with the Indian Navy. So the Navy wanted such a system for them. And L&T is a partner through whom we are able to deliver this technology to them. And then power electronics, we have a national mission on power electronics, which we call as NAMPED, through which we are able to develop new horizon technologies, DC-DC converters, inverters, drive systems. And there's one thing notable is about the VCU, which is called Vehicle Control Unit. This is the brain of all the engine control which is happening in the loco, the railway loco that we use today. More than 2,000 such railway locos use our technologies to drive all their engines there. And this is done, and then design is done by C-DAC and given to TOT industry partners. Subsequently, it is being manufactured out of ChipIN local box. IoT, so we have done a lot of work in IoT and this thing. So going on, National Supercomputing Mission, which we call NSM, is a funded project by Ministry of Electronics, IT, and Department of Science and Technology. The implementation partners are Indian Institute of Science, Bangalore, and C-DAC. So this started up a few years back. And so far, we have been able to deploy about 35 supercomputers across the country, which we call Param series of computers, Param Shivai, Param, everything starts with a Param. In Tamil Nadu, we have one in NIT Tirchi, which we call Param Purul. So this facility is available for the entire NIT Tirchi. The NIT Tirchi could claim about 60% compute of that, and the remaining 40% for the institutes around this area. More than 10,000 researchers and 2,000 plus institutes and PhD scholars are already trained and acquired skills on these machines. And we have something called Param Siddhi AI and Airavat machine. This is the biggest machine in India, and it is ranked 75th in the top 500 supercomputer list in Germany, which was listed last time in Germany last year. And this year, we were able to again clock to the same level by adding Airavat to it. So it's a HPC plus AI intense compute. It is located in CDAC, Pune. A lot of works have happened on this, including what we were able to help identify people, who using the Aadhaar database, the people who got affected during the Balasur incident. We were able to identify the mutilated faces from there and identify the right person and send the people and get some relief done to them. And then we have this Param Rudra, it's HPC indigenously designed and developed system. What you see on the right is a 2U and 1U system of Param Rudra. And the cluster is based on out of that Param Rudra. It's Param Rudra, we call it Param Rudra 1. It is based on the Intel Cascade Lake processor, and it's a high density node. So we use this node it was indigenously designed, developed, and manufactured within the country. In the past, we used to buy and keep machines, and then we were able to get parts and pieces and then assemble that and keep in the country. But today we have the capability to design, manufacture, assemble, and commission the machines within the country. Going forward, we want to have our own processor. Today, we use the Intel processor, but we wanted to have our own processor, which we call as OM processor. This is an ARM-based architecture. It's a HPC class. It has about 96 cores in one socket. So this will be the first of the kind, and we are the 4th country worldwide to attempt this particular processor design. The work is in progress, and we will have this chip tape out end of next year, and 2 years from now, we'll have systems based out of this. This will be highly efficient, both in terms of speed and in terms of power utilization. Today, if you want to set up an exascale machine, you need a 40 megawatt power system. But we are attempting to make it less than 50% of the power that is used today. And also make it very compact. That is the ambition that we are up to. A lot of applications have been developed in this past few years. Few of them is the urban modeling, flood predictions, and forest fire forecast, predicting how forest fire can spread. Seismic imaging is something is necessary for identifying potential areas to make the offshore drills. This is being used by Indian Oil and for gas exploration. Drug discovery is another major thing. During the COVID, our Param Siddhi AI machine was used to repurpose certain drugs so that it can be used effectively against COVID. So the idea is to simulate as to how these molecules, protein molecules of the drug can combine with the COVID virus and then take it out of the system. If you had to do it normally, you would have to go through a lot of trials. Costly and risky trials on human trials, and it will be time consuming. But with this system and by simulation, we are able to eliminate some trials, which is not necessary, and only focus on something which is going to give us success. And these machines can run quick time to give you those results, and we are able to do that. We are able to repurpose drug, and we worked around with Lupin Pharma at that time. What you see on the right, our Honorable Prime Minister Modi was visiting one of our stall and is very keen to understand what is supercomputing, what is the machine, how it has been designed within the country, and all that. These are the three systems that were dedicated to the nation by our Honorable Prime Minister. This happened in September 26th last year. The first one is the Inter-University Accelerating Center in New Delhi. So IUAC is an Inter-University Accelerating Center, which means they run like the Sun the accelerator. They also have a smaller size accelerator on-premise. These accelerators, they accelerate particles, electron beam, and do experiments when they bombard against certain particles. And when they are elaborate experiments. Normally, the setting up of the experiment takes about a few days, and then afterwards, there's a lot of radiation in and around, and nobody goes near that. And later, they shut it down, and 3-4 days after only, people can approach that and take results, have a look at the results. So now, with this machine, the machine which was given to them, which is one of a decent sized machine, which is a 3 petaflop. People can do such simulations. They can do, instead of doing the actual experiment, they can look at how particles behave using simulator. There are softwares which run on these parallel machines, and they can give quick time results. And then they can avoid actually running on that accelerator, and then concentrate only on certain things which we are very sure that we'll be able to make out something new. So this is an accelerating center available for any researchers across the country. It's dedicated to the nation. It's fully available. And then we have the NCRA. It's a radio astrophysics lab in Pune. So we have a large array telescope through which they send receive radio from the space. So this is an establishment done with the international cooperation. A lot of European agencies are also part of this. Here also this machine is given. It's also a Param Rudra machine, totally indigenously developed machine in the country. One specialty about this is it can do real-time analysis of the data. So it can gather data real-time and process that and give you results for that. And third one is the SN Bose center in Kolkata. It's also a sub-petaflop machine. And then we have a New Delhi a machine which is very small, that is 200 teraflop, but we are gradually going to increase the capacity of that. This machine is fully dedicated to the students of the country. All the students, engineering students, college students, or school students, anyone could use this. They can take a login to this, they can start using this, develop application, run the applications with that. But today it is so small that now we are offering it to about 2,000 students so far. But going forward, we'll be increasing the capacity so more students can be onboarded and they can start using this. So these are Rudra series of servers. So we have Rudra 1 and Rudra 2 is in the design phase. We have both an Intel variant and an AMD variant. So ideally, what you see on the right bottom is the eight GPUs in one system. So this is equivalent to NVIDIA's DGX box. So with which you can do a lot of AI computing. So normally 4 of such thing goes into a rack, and then you have multiples of those racks. So this is a design in progress. And next month, World Mobile Congress, we are going to launch this product in Barcelona. We also have other industry partners like BVD and Keynes and Avalon who are already manufacturing these machines. If somebody would like to procure this, they can place an order on top of them, and then some of them are already available on GEM platform. Okay, this is an interesting thing. This is a Param Shavak, HPC on your desktop. So if somebody is not able to get access to the clusters that we have already created or cannot afford a big machine on premise, they can start small. This is an HPC on a desktop with which it runs every software that an HPC runs, HPC cluster runs, so that people can get a feel of what an HPC is all about, get to experiment with the softwares, write applications on top of that, and see how it scales up. The moment you outgrow this mission, you can always have a connectivity to our clusters. As I told you before, the 60% capacity of the Paramporul in Trichy, NIT Trichy, is meant for the local institute, but the remaining 40% is available for the rest of the institutes outside of NIT Trichy. So you can connect to that machine and expand your experiments on top of that. You can do HPC, deep learning, virtual reality, bioinformatics, all of these applications can be done. You can do computational fluid dynamics, molecular dynamics, materials reengineering, all of works can be done on this machine. The next one is our RISC for Digital India RISC-V, which we call it DIRV program. The aim of this project is to create a series of processors and reusable IPs and create 32-64-bit RISC-V processor, which we call as Vega processor, and associated peripheral IPs, and make this ecosystem fully available for the community, which is the students, the researchers, MSMEs, and the startups. So we provide the complete resources like all the IPs, softwares, IDE environments, and the whole lot, so that people can make new designs out of this. So far, we have done 3 chip tapeouts. One is a 32-bit processor, which the chip has come back to us, and the last year we are able to make repeated orders because it's a lot. It has got a lot of demand, and it is also available on Amazon. People can go and buy that from Amazon, and then we have procured and given it to a lot of institutes so that it becomes part of the curriculum. Today, IIT Kanpur uses this. IIT Gandhinagar uses this part of their program. So NELIT is conducting a lot of courses on top of this program. This is an equivalent of a TMS processor used in Arduino boards. So it's exact replacement for that. And it does everything that Arduino board does. And then we have the 64. It's a full-fledged RISC-V processor, which can run Linux operating system on top of it. And this is done in SCL, which means complete indigenous design, manufactured, and packaged, assembled in the country. So it runs at about 100 megahertz because the technology node is 180 nanometer. We work very closely with SCL to make sure that we could use a better libraries like standard cells, so that we are able to condense the size of the standard cells. So we, instead of 4-layer, we moved to 6-layer, 6 metal layer, so that we can have a compact design. And this is also power efficient. And these 2 chips can be used extensively in low power and low value, high volume applications. And then we also taped out a dual core variant of this, which is in TSMC 22 nanometer, which will run at close to 1 gigahertz. And we are expecting the chip anytime now. Once we have that, that could become a candidate for thin clients. You can have a desktop computer running on top of that as a thin client, and many other applications is possible with that. Today, we are engaging with MSMEs and startups. They take our core, they integrate with them. And one such application is going to be a GPON. GPON is Gigabit Passive Optical Network chip. This is the chip that you see in every home today. The Airtel or the Jio or the BSNL, they all terminate onto this chip. And it is completely imported from China. So this particular product, which is under development, will replace all of that. Close to 1 crore demand per year is what we expect. And then we have the Iris series of boards. These are different kinds of boards that they have developed for different applications. All of this is available on Amazon, and we have also shipped to many institutions so that students can start working those. Reference designs, reference schematics are already available on the portal. We have a portal called vegaprocessor.in, wherein you can find the details of all of these boards. Next is the ChipIN Center. ChipIN Center is C-DAC Center in Bangalore. This is a single window, one-stop center which offers all the EDA tools, virtual prototyping for chip designers in the country, both students, startups, MSMEs, and the complete academia. What we offer from this here is all the license that is necessary to go through an end-to-end and chip design flow, starting from simulation to synthesis to DFT to place and route, and for packaging tools. All of that tools, whatever EDA tools you require, is being hosted from here. The licenses are served for the entire country. We started with 100 institutes, that are the original upload. Later on, because of the demand, we increased the scope, and today we have more than 250 institutes onboarded, only using the EDA tools. I'm sure R.M.D also is part of the program. If not, it's not that difficult. We can onboard them and you can start. The only requirement is the course. You should have a course which teaches VLSI in the college. Through this program, the students can tape out chips. It doesn't matter whether it's a complex chip design or a simple chip. It could be a simple A to D or a D to DAC chip, or a very simple logic design, or even a complex chip, a processor. Any of that is possible, but only restriction is the design should be a 5 by 5 mm, 5 mm by 5 mm chip, so that we give opportunity for other designers also to latch on to that particular shuttle. So the shuttle is something where multiple designers come together to book a wafer and then the mask on top of that. Because the mask making is too expensive, so instead of having one design on top of it, we'll have multiple design and share the cost. So this center from Bangalore facilitates all of this. So we take the GDS2 layout from the students, and we do the sanity check and make sure this GDS2 is fabricated by our foundries. We have identified few foundries like IMEC, Belgium, and TSMC. We get this design done from them and then subsequently packaged and deliver the chip to the students so that they can do the testing in their facility. We also offer some test facilities in C-DAC, and we also have some collaboration with industry, so their test facility could also be used for them. And we also have something called design linked incentive. So the students who today could become a startup tomorrow, and then they can start doing bigger chips, which will go to market and have an impact on that. So Government of India has come out with a scheme called a design linked incentive scheme. Under this scheme, if you have a startup or MSME, you are eligible to get a grant of about 15 crores rupees. Suppose you have a 30 crore worth project, and you estimated your project is going to be a 30 crore, out of which 15 crore grant will come from the government in a reimbursement mode. So basically you have to spend and then claim the money. And then month on month, you can have a rotation so that your contribution is limited to 50%, and the rest comes from the government. So the idea behind this is to retain talent within the country, create IPR, and increase the investment on chip design and related activity. So under the India Semiconductor Mission program, so government is giving this opportunity for any startups to come and take this incentive. My only wish is the RMK group of engineering college students, they should graduate themselves to become a startup and start using these incentives given by the government. Today, it has been limited to 100, but I think there's DLA scheme 2, which is coming up, version 2.0 coming up. So there we'll have more numbers, and even the budget could be increased from 15 crores to more also. That's a possibility. But it's awaiting cabinet approval. So under the chip to startup program, I mean, through this, which is already going on, this will continue for the next 2-3 years. 85,000 manpower has been trained in VLSI. There have been courses which are retrofitted with a specific VLSI domain. And we are given EDA tool access, lab facilities, 50 plus patents have been published. And we have supported more than 25 startups. It's a very small number, but we expect this to grow. This is a pie chart of how the institutes have benefited out of this program. So we have about 32 states already onboarded. I mean, within them, a lot of IITs, NITs, IIITs, private institutes like yours, and then government institutes. All of them are part of this. They either use tools only, or they also come for funding to do small projects, small tapeouts. Basically, it is about the department, HODs and faculties. They identify some startup, and along with the startup and the students and the faculty, they make a proposal to do a particular chip design. And that chip design is fully funded by the government. Yeah. So far to this phase, we have completed 65 projects, and 50 more are in pipeline. I mean, people are ready with the design. We have to take it up for a tapeout. Yes. The quantum initiatives of C-DAC, we are part of the National Quantum Mission Technology Hubs, computing, communication, and then sensing. So we are part of the neutral atoms, ion traps, and a lot of work is happening in the communication, and then water quality, air quality testing using sensors, quantum sensors. These are work in progress. So if you look at what is quantum computing, it's a big machine where if you take the multiple ways you can accomplish a quantum computer. One is by photonics itself. Another one is superconducting semiconductor, which has to be cooled sub-zero of temperatures. You should not cool it quickly. You should cool it gradually so that the semiconductor doesn't break away. So what you see in the top bottom right is the machine. It's a big complex machine where cryo fuel is used to, and a dilution refrigerator is used to bring down the temperature of the semiconductor thing, so that you can activate the qubits in that. And then what you see on the right is the control and readout electronics. The control is the one which will try to stabilize the qubit, and the readout is the one very similar to your heterodyne transceivers, right? Where you try to mix your incoming frequency and convert that into an IF and subsequently extract the information. Something like that happens on the readout side. And the most important thing is how to control these qubits and correct the errors. These are all done using FPGA, multiple algorithms run on them. So C-DAC is working on these areas. But meantime, we also, the last few years, we have offered QSIM, it's a quantum simulator, so that people can have a feel of what will be a real quantum mission when it happens. So this simulator, students were able to run applications on these simulators, I mean, develop application and run on them. It was very slow because it was running on a laptop or a single node server. But going forward, we thought that it has to be accelerated. The simulator itself has to be accelerated. So we find the GPU is a good candidate, the general purpose process, GPUs. And then there are accelerators which are vector based. And then there are active accelerator which you can customize on an FPGA. So there are 3 different variants of this already available. The designs are there, and a lot of work is happening, where this simulator could be accelerated, and we can go close to, not close, maybe less than 10% of the actual quantum machine. Quantum communication, I mean, this is very important that, to avoid man-in-the-middle attack, it is essential that we all migrate to quantum key distribution. So what is happening here is a single photon is transmitted between Alex and Bob. In terms of quantum, we talk about Alex. The one who sends is Alex, and the one receives the Bob. So you send one single photon from one place to another place, and make sure nobody intrudes. If somebody in the basic principle of quantum is that you can't measure unless you get the juice out of it, which means let me explain to you in other words. In your labs, you would have seen oscilloscopes and DSO. This is single oscilloscope, right? All of that will have high impedance input probes, which means these high impedance probes will not load the signal. These signals are low voltage, low power signals. If you load them, you will be essentially destroying the signal itself and you will not read out the actual signal. So therefore, you have this high impedance probes. Similarly, in quantum world also, if you read a quantum phenomena, you are essentially destroying the element. So this principle is put to use in the quantum key distribution. If somebody, man in the middle, tries to snoop and find out what you're trying to communicate, is essentially destroying the quantum physics there. So you can easily detect. This can be detected and you avoid using that particular thing. So you need to be line of sight. I mean, if you are in optics, okay, you can have large spool of optical cable and you can or run through multiple buildings or cities. Or if you are on the space, you want to distribute some far apart two different objects who are not connected by any optical cable, you do a free space quantum key distribution. So all of these cases, you make sure that you deliver this key so that nobody is able to snoop around that. So we have developed hardware for that. This such hardware has been deployed in and around Chennai's IIT Madras, and then we have sets, and then we have IIT Research Park, in which we have R.M.D. R.M.D. is another organization. All these institutes have a quantum key distribution network, so that these keys can. This is just a test bed today, but going forward, we'll be doing the same thing for about more than 2,000 kilometers across the country, and that is called Project Quila. So what is here right is the hardware that we did, but there are a lot of work to be done. I mean, if you run long cables from one city to another, you can't expect the cables to go without any break or slicing or splicing. You would need repeaters there. So you need a single photon detector and a repeater. So this is something to do with materials. So our sister concern CMET is working on that, so that we can detect a single photon and subsequently repeat that without any man in the middle, or without converting the photonics to electrical and subsequently electrical to photon, without doing all that and avoid any man in the middle. This is a work in process. So our ambition is to have a quantum operating system, right? So that is a long way away. We don't have it today, but we are trying to have the building blocks of that. We're trying to have an SDK so that algorithms can be implemented, libraries, compilers, profilers, all of that has to be done upfront, so that once we have an actual machine, then you can run these compiler softwares and the SDK along with the SDKs, so that you can inch towards the quantum operating system. So this is effort in that direction. Similarly, quantum sensing, I explained already about the single photon detector repeater. This is the experimental setup. Yeah, next we have this national blockchain framework. So what is blockchain? Blockchain is a platform by which you bring, I mean, it's not a solution for any application, any web application. Application has to be carefully thought about before bringing them onto blockchain. So blockchain is about bringing untrustworthy transactions or untrustworthy any of that to a trustworthy platform. So blockchain does that. So it records, it maintains, it ensures that it is not tampered with. So if you have to tamper one entry on a blockchain, it's a simple ledger. So it's a continuous sequence of ledger entries and then continues from one page to another page and the book to another book. So if you want to change one entry in that, I mean, you want to manipulate that, it's very difficult. You have to compromise the entire chain, entire ledger, entire book after book. So that is not possible because it is chained. It is encryptions are chained and they are subsequently used to create the next entry. So we have developed this platform. It is being put to use by many government agencies. Even certificates are being distributed to this. E-stamp, there's some application. Yes, here it is. There are some applications already onboarded. The e-stamp solutions are there. You can have a e-voting on top of this. certificates are being issued on with this. So it's right now it is being implemented in 3 data centers. I mean, even the data centers are they don't trust each other. That is the fundamentals of this. So we have 3 data center, Hyderabad, Pune, and Bhubaneswar, managed by 3 different agencies, so that they come to a consensus when an entry has to be made. So even the property registration. So it's all about the consensus and having smart contracts, and it's basically about bringing untrustworthy environment to become a more trustworthy environment, like letter of credit, which you want to give to somebody who's making a business with outside the country. So we bring them on this platform, have a smart contract, and you have exit clause and entry clause, so that you can manage the whole thing in a very transparent and trustworthy manner. SwaYaan, this is a capacity building program to increase the capability of students and the MSMEs and the startups in design development of unmanned aircraft systems across the country. So it has been divided into all regions: North Zone, South, East, West, and all the institutes have been grouped geographically and also domain-wise. The aim is to build skilling and development of a different part of the drone, from the motor to the materials used in the magnets, the chassis of the drone, and the propellers and the battery system, controllers, the gyro, the accelerometers, and all of that. So to encourage people to understand, learn, and innovate in these areas, we have created 50 plus courses in MTech, and there are multiple majors and minors. We have done retrofitting of the courses. We have trained faculty members. We have given hackathons so that people can participate and then innovate in all of these verticals. So this is a work in progress. A lot of students are benefited. This week in Aero India and Bangalore, we have a lot of display from these students, the students who have been benefited out of this. They are coming there and they are displaying their products which they have developed under this program. Okay, this is another program. It's a information security education awareness. Cybersecurity has been a big problem at different levels. So we try to provide courses, retrofitted MTech, BTech, so that people are aware of and they go deep dive into information security, cyber security. And also we conduct large scale awareness programs. So we go and do, along with the police department, along with the banks, we do a lot of awareness programs. We conduct a lot of workshops. So workshop on demand, there's a portal on which you can demand a workshop there. And then we come and give a lecture about cyber hygiene, about how to protect yourself from cyber frauds and all of that. So a lot of people get trained in this program from all these academic institutes. So they get to the international class certificates, which is normally very expensive, and you have to pay in dollars to get those. But similar courses have been run by this program. We have a common infrastructure wherein you can run your exercises, like capture the flag exercise. You want to create an environment virtually on a cloud environment and create a problem there, and then have a blue team and red team work simultaneously to resolve that particular thing. The entire ecosystem is available through this program. So any institutes can come on board and start using this. Okay, Future Skills Prime is a program which is done by Ministry of Electronics IT along with NASSCOM. So we have seen a gap in, when people want to advance in career, we see there's a gap in the skill set. So the NASSCOM has come out with a list of courses which will be relevant, and subsequently, if somebody goes through that, they become industry relevant and they get placed easily. Or if they're in mid career and whatever they know is obsolete and they want to upgrade their skills, all of that is possible through this program. So what is available here is a complete reimbursement of their course fees, provided they clear an assessment. So this is run by NEEL, C-DAC, and other institutes across the country. So basically, it's an hybrid mode program. So that you can complete the program and then come for an assessment and claim the reimbursement. So there's a small fee, and that fee comes back to you once you are able to. Workplace Learning Scheme is another program, is specifically meant for SC/ST women and EWS candidates. Here, a student is eligible from semester 7 and 8. So it's normally a 6 months program. What we do here is we train people, they work along with our staff. I mean, not only CDAC, CMAT, CERTIN, ERNET, NEELET, SAMIR, and STQC. The students are selected through a AICT portal. So they come to the AICT portal and there they register for this program and show their interest and which domain they want to work and which institute they want to associate with. Depending on that, AICT will scrutinize and send applications to these centers. And will have a, normally it's only each CDAC center, we have 12 of that. Each CDAC has got only 30 seat limitation. So if there are more applications, we'll have to do a screening of the application, maybe a test or something of that sort. But what happens here is they get to work with the engineers of CDAC on real problems, what is happening today, which is being executed by them. And they also get a monthly stipend. So which is close to about 10,000 rupees is what they get. Initially, it is given for 6 months, and subsequently it can be extended for another 6 months also. This is something RMK group of institutions can. These are the courses which we conduct under this program: cybersecurity, quantum computing, AR, VR, blockchain, smart cities, IoT, health informatics, language, computing, digital preservation is a very big area. Flexible electronics, 3D, robotics, AI, machine learning, big data, all of that. Okay. CDAC also conducts a PG diploma program. A lot of them, about 10 different PG diploma programs are already being conducted. We conduct JEE kind of examination across India when we select about 6,000 people and then do the counseling to join these courses. We started this program when the mission started, that is in 1988, when we had this first CDAC mission of making the Param mission. We could not find people who can work in parallel computing. There were nobody who can write parallel programming. So that is that was the reason we started this PG diploma program. And that time we were able to consume all of the 100% into CDAC stream. But today, all the people find placements elsewhere. Today we have run all this program. The students go and get employed in big companies, Qualcomm like company, Intel, AMD. And more than 80% get placed outside. We are left out only with just 10 to 20% for our own consumption. So this is after school, after your college, this is something you can take up for upgrading and getting into employment. We do a lot of exams. We conduct a lot of exams across the country. A lot of Agniveer, Agni Vayu, these kind of exams we already do for Navy and Army, Air Force. So we have technology to do that. This is a split of major and minor areas of our focus across CDAC center. Bangalore, Chennai, Hyderabad, Kolkata, Mohali, Mumbai, Noida, Pune, and Delhi. In Delhi is an international, we focus mostly on international cooperation from Delhi. We have about 40, we have a presence about 43 countries worldwide, especially Africa, South America, and then former USSR, some of the countries within them, and Southeast Asia. I mean, Fiji Islands and all of that. We have an ICT academy. So initially our people go there and run the show for about 1 or 2 years and then bring up their capability so that that center can be run on their own. This is all about CDAC. I hope that my presentation is will really help students to become entrepreneurs in the future, become MSMEs, startups, and they can benefit a lot from all the government is offering, especially the real estate, and hope it helps. I can take questions. Thank you. Thanks for the opportunity. Thank you.
Thank you, sir, for your enlightening words. Your insights will undoubtedly leave a lasting impact on our students. We are truly honored to have you with us today, sir. To conclude our session, we now call upon Ms. P. Rajeshwari, Assistant Professor, Department of General Engineering, to propose the vote of thanks. Please, ma'am.
Thank you, ma'am. It gives me immense pleasure to propose the vote of thanks on behalf of Science and Humanities Department, R.M.D. Engineering College. I would like to thank the management for giving us the opportunity to invite guests for generic talk series. I wish to thank our chief guest of the day, Shri E. MAGESH, Director General, C-DAC Pune. Sir, it is really an informative session. I am pretty sure the precious knowledge you gave us, like a quantum communication, blockchain framework, EDA tools, fabrication and design services, National Supercomputing Mission, Paramrudra supercomputers, Vega processor development and its applications, ChipIN Center, which is one-stop center for chip designers across the country, will help our students in their future. Now I thank our principal, Dr. N. Anbuchalian, who always chooses the best among the options and consistently works for the betterment of students. I would like to thank our Dean Research, Dr. K.K. Tyagarajan, who is keen in research and supporting, motivating us in all our research activities. I also thank Professor Dr. V. Chamilchelvi, Head of Science and Humanities Department, who has always been a backbone in guiding us in all our endeavors. As we bring this incredible event to a close, I would like to thank Professor Dr. P. Usharani, the organizer of this generic talk series, Ms. Meetpin Arasi, Assistant Professor for the comparing, and Dr. S. Shalini, Associate Professor, for sharing the welcome address. Last but not least, I want to thank every one of you, our attendees, for being here with us today. Thank you, ma'am.
Thank you, ma'am. Thank you all for being a part of this event. We look forward to seeing you again soon. Have a wonderful
Thank you, Magesh. Thank you very much for your kind cooperation and invited our invitation, and you have delivered a lot for our students for about C-DAC. Thank you very much.
Thank you. Thank you very much.